Greetings, ladies and gentlemen. We're going to go over some of the basics of matrices today. Hopefully you pulled up this note paper and you can kind of follow along with what's going on. So we've just finished our unit about solving systems of equations, and then we had systems of inequalities a little bit there. But we're going to get back to solving systems. And we're going to use a slightly different method. It's using these things called matrices. What a matrix is basically just a box with numbers in it. So this is a lovely box. It's got numbers in it. Each of these numbers is called an element of the matrix. And a matrix has a certain number of rows of numbers and a certain number of rows of numbers. So this one here has 2 rows and then 3 columns of numbers. Rows go horizontally, columns go vertically, like columns go vertically in real life. And so we can write the dimensions or the size of a matrix based on the number of rows and columns. And so this first one here is 2 rows and 3 columns. So we call it a 2 by 3 matrix. This one here has 3 rows and 3 columns, so it would be a 3 by 3 matrix. Those are bad 3s, but yes. And then my last one here, it's kind of weird. It's skinny, but it only has 1 row going across, but it does have 4 columns of entries. Even though there's not very many things in the columns, it's still columns. So this is 1 row by 4 columns. So remember, which one goes first is rows, and then it's columns, and columns go up and down, just like in real life. So now that you've kind of seen matrices, they're just boxes with numbers in them, and they have certain sizes. You can actually add and subtract matrices. And the way you do that is you just add the corresponding elements. So if I wanted to add these 2 matrices together, I would add the first elements together. And then I would add the second elements together. And then I would add the third ones together. You add the ones that are in the corresponding positions. So this one matches this one matches this one, and this one matches this one, and now I've just drawn all over it and made a big mess. So let's kind of show you what that looks like. 2 plus 3 is going to be 5. Hooray! Next one here, -4 plus 4, -4 plus 4 is going to give you 0. And then my next one is 0 plus -1 gives me -1. And then you can do the same for the bottom row. -1 plus 7 is 6. 3 plus 0 is 3, and 5 plus -2 is 3. So we got our last row there. And so that's how it works. Let's kind of show what it looks like. This one is subtracting. So you're going to do the first element, subtract the second one. What is 3 minus 1? Hopefully you said 2. Yeah, so this first one's 3 minus 1, which is going to be 2. And then my next one, I got 4 minus 7. So if I was writing out all the work, I got 4 minus 7, which is going to be -3. Next row, I got -2 minus -8. Remember, when you minus negative, same thing as add positive, so it's -2 plus 8. And my last one, 0 minus 1. Should be pretty quick to figure out. And then we'll get 6 and -1. So there you can add it up. I'm okay if you go straight from here to here. A lot of it's really just like adding 2 numbers together, subtracting 2 numbers, so it's pretty quick, pretty easy. Let's look at this third example. We're going to get 2 plus 3, and then -4 plus 4, and then 0 plus... Oh no, there is nothing here. 0 doesn't have anything to add with, and 5 doesn't have anything to add with. Oh no, the problem is broken. And yeah, really it's broken. You can't do this. It would be undefined. And so that's something that's interesting about matrices. Something like just adding 2 of them can be impossible. And when you're adding and subtracting matrices, they have to be the same size. So this one is a 2 by 3 because it's got 2 rows and 3 columns, but this one's only a 2 by 2. It only has 2 columns and 2 rows. And so these are not the same size, and so you can't add them. We couldn't subtract them either. So that's very important to remember. And another thing, you can do with matrices is you can multiply them by something called a scalar. A scalar is a number that's not in a matrix. It's just a single number. And the way that works is you really just distribute the number to everything inside. So 4 times 2, 4 times 1, 4 times negative 3, 4 times 9, 4 times 0, 4 times negative 5. You can see all the 4 times those. And you get this result here. So it's pretty easy. We can distribute this 1/2 through to all of these. Let's see, we get 7 halves, which is 3.5. 8 halves, which is 4. Negative 10 divided by 2 is negative 5. And then 6 divided by 2 is 3. And then 0.4 divided by 2 is 0.2. And so I got my resulting matrix there. So not only can you do that, but you can also combine those two ideas together. So you can multiply a matrix by a scalar and then subtract or add them. So I'm going to take 2 and distribute it through. And then here you can take 3 and distribute it through. I want to point out that if you decide to distribute negative 3, then you would then add the matrices. If you decide to just distribute the 3, then you're still going to subtract them. And on your paper, it has the subtract here still. And so we're just going to distribute that 3 through. So you can get 10, negative 6, 0, negative 12. My other one's going to be 9, 12, negative 3, and 21. And then I'm going to subtract them. 10 minus 9 is 1. Negative 6 minus 12 is negative 18. 0 minus negative 3 is 3. And negative 12 minus 21 is negative 33. Voila. So there you go. And then one last thing for the notes today. When you're looking for names of matrices, we usually use capital letters. So this would be like matrix A would be capital A. And then scalars, or smaller numbers, just single numbers, we typically give just a single lowercase variable like A or B or X, things like that. And so we're just going to look at a couple of examples from your assignment here. Let's jump to, we already went over how to add, subtract, multiply by a scalar. I want to look at some on the back, because some on the back are actually equations, and you need to solve the equation for this mysterious matrix A. Well, before we do that, I want to just we're just going to look at it for a second. Pretend it's like 5 minus A equals 11. If you wanted to solve this equation, you can just subtract 5. It's going to be 6. And then divide by negative 1 or times by negative 1. And then you got your A figured out. Okay, we're going to do the same thing, but instead of just subtracting a single number and whatnot, we're going to use entire matrices at once, which might seem a little daunting, but it's actually really easy. And so I'm going to move this entire matrix over here by subtracting it off. So subtract 2, 6, 8, negative 5. And subtract 2, 6, 8, negative 5. Now I got negative A equals, see, negative 4 minus 2 is going to give me negative 6. 3 minus 6 is negative 3. 2 minus 8 is negative 6. And then 1 minus negative 5 is going to be positive 6. So I got this. And I do need to get rid of that negative. You can multiply or divide by a negative. I'm just times by negative 1. Times by negative 1. And this is just multiplying by a scalar. So I could times the whole thing by negative 1 to get positive 6, positive 3, positive 6, and negative 6. And voila, there's my matrix. If I were to take this original one and subtract this one, I would get this one. So there you go. That's kind of the process. And then I want to point out one other thing is sometimes in your scalar or entries in here, they can have variables, and you'll still distribute to everything. You just have to remember how to multiply things with variables together. This first one, 5 times negative 2c is going to be negative 10 a to the third c. You just put them together like that. But if a term also already has an a, you're going to add the exponent on there. So this becomes negative 5a. Well, this is 3 a's times together. You get times by another a, so that's 4 a's times together. So it becomes a to the fourth. And then you can go through the rest of these. If they have different variables, you just put them next to each other. If they have the same variable, you're going to add the exponent. And there you go.